Okay, in this video we're going to look at simultaneous equations and solving them using the substitution method. So there's three methods you can use. So remember there's the CAS calculator and there's a video on this link here. So if you're planning on not doing any maths, you can just answer all the all the simultaneous equations using CAS. Although I encourage you to just look at the substitution ones as well, because the substitution questions in this sheet here aren't too difficult. They do get a little bit difficult in the textbook, but the ones on this sheet aren't. Now, before we move on, let's have a look at what a simultaneous equation is. So simultaneous equations basically are two lines that cross. So you can see here in this example that the blue and the red line cross. And because there's a point of intersection, we call that the solution. Now, the only situation where we don't have a solution is when they're parallel lines. Okay, and you also have another solution where they're the same line, but we just need to think, well, in this case, they either cross or they're parallel. And if you think of parallel lines, like the lines on your piece of paper, they'll never meet. So therefore, you can't have a solution. All right, I'm going to skip the examples here because you can read them yourself, and I'm going to go straight into maybe just one of the practice questions here, and then I'm going to have a look at some of the textbook ones as well. Okay, so let's have a look at, I don't know, I always do A, so let's have a look at doing D. Now, the good thing about these two equations is we have this y equals part. When you're doing substitution, you either need y equals or x equals. So I'm going to just rewrite the equations here. So we have y equals x minus 1 and 3x plus 2y equals 8. The substitution method, just like you've done substitution before, but you've done it with numbers, not really equations. So we have this x minus 1, and because it's y equals x minus 1, this y here is also x minus 1. So when we rewrite this second equation, instead of having 3x plus 2y, we can write it as, so I'm just changing the colour there, come on, 3x plus 2, and instead of the y, I'm going to put in brackets x minus 1 equals 8. And then I can, because I've only got one variable, which is x, I can solve for x, whereas here I had x and y, and I can't solve when I've got 2. Okay, so let's expand that bracket. We have 2x minus 2 equals 8. 3x plus 2x is 5x. 8. And then I'm going to bring that 2 over, so it becomes 10. So x is equal to 2. Now, in simultaneous equations, there's always a bit of working, so I always like to put, once you've found one solution, put a square around it. Now, to get y, because we've got y equals here, and I found out before that x is equal to 2, so I'm going to have 2 minus 1, so y is equal to 1. And there's my other solution. Now, what I've done there is enough to satisfy, but if you say the point of intersection, okay, so remember these are the coordinates of a point of intersection, so your point of intersection is 2, 1. And I'm just going to quickly show you that graphically. Okay, so if we have a pair of axes, and this isn't going to be the exact graph. Oh, I keep pressing on the wrong button. Okay, so let's say, all right, okay, so there's one line and there's the other line. So this point of intersection here is the point 2, 1. So that's basically what you're finding out. I'm just going to pause it for a minute to get your textbook up. All right, so in question 4 in your textbook, you can see you've got a bunch of equations where it's y equals, and then towards the end here, we have x equals. Okay, so these ones here are all x equals. So you do the substitution exactly the same way. So if we look at x, so our first equation is x equals 2y plus 3. So wherever I see x in this equation, which is here, I'm going to substitute that in. So I'm just going to delete that because otherwise I can't read the equation. So some people like to call that equation 1. So I'm going to sub in into equation 2. You don't have to write that. So we have 11y minus 5. So remember x is 2y plus 3 equals negative 14. So it works the same way even though we have, just be careful if that negative applies to the 3 as well. Because we're dealing with y, it works exactly the same way. Okay, so 11 minus 10 is 1y minus 15 equals negative 14. So y is equal to 1. And then we just substitute that back in. Y equals 1. I'm running out of space, so I'm just going to do it up here. So if I put 1 in there, 2 times 1 is 2, so that's 5. Okay, and hopefully you know how to do it on CAS, so you can check your answer. Alternatively, you can substitute them back into your equations, and if the left-hand side equals the right-hand side, you've done it correctly. Well done.